Okay, so we're gonna get through 3.1 as much as possible today. We deal with some word problems towards the end that might take a little bit. So wherever we end that will be fine. An exponential function, these are gross to graph, they involve decimals. If you've got your calculator today, I'll show you how to type them in. And for those of you that don't have a calculator, I'm gonna get batteries and then I'm gonna clean these and get these set up so that we can start using them. The exponential function has a base, b, and what makes an exponential function is that your variable, of course, is in the exponent area. The base has to be any number other than 1. And the reason is, of course, if you had 1 to any power, you get 1, and that would turn into y equals a constant, which is actually a horizontal line. So it wouldn't even be an exponential function. B also has to be greater than 0 because 0 raised to any power is what? 1. So some basic examples of exponential functions you'll see at the top left of that paper I just gave you. F of x equals 2 to the x, g of x equals 10 to the x. Where do exponential functions, or what are exponential functions used to model? What are we going through right now? All right, we're going through COVID, which of course, one person sits here and then they're infected and it can spread to the next person who spreads it to even more people. So that's an exponential growth. Exponential decay. Of course, you've got rotting things that rot. So those can be used to model exponential functions, which we're going to see. Any of you ever heard of the Chernobyl disaster, the nuclear lab that exploded? So of course, there's an exponential function that represents that situation and is used to figure out the years after a certain thing that happened to see when that area will be habitable again by humans and safe. Okay, so all of these functions are going to have a constant base. That's what B represents, is any constant other than, of course, it can't be equal to 1 and it has to be greater than 0. All right, the first problem we're going to look at actually does involve a word problem. So if you can see that up at the top of your notes, I'm trying to zoom in. It'll be hard for us to see, but just look on your notes. People get thrown off by these word problems because, of course, it looks very intimidating at first, but problems like this are very simple. You've got this function that models the average amount spent in dollars at a shopping mall after X hours. So exponential functions are also used by analysts to determine, okay, well, if we can keep these shoppers in this area for longer, then the chances are they're going to spend a lot more money. So it says, what is the average amount spent to the nearest dollar after 4 hours? And they tell you that X is what? The X is your hours good, and that's 4. So all you're going to do is plug in 4 for X, and you will need a calculator either on your phone if you don't have a scientific or graphing something. So as you see, all I did was plug in 4, and then you type all of this in. 42.2 times 1.56 to the 4th power, and they tell you to round to the nearest what? Dollar. So please make sure you're rounding correctly in this. In MATLAB, they're going to be particular about it too. So you should get $250. So after about 4 hours, the average shopper spends $250. Then on this second part, it's asking what is the average amount spent after 3 hours. So once again, plug in 3 for X and type that into your calculator, and you get approximately $160. So as you can see, after 3 hours, they average this amount spent. After 4 hours, average this amount spent. And so 5 hours would be, of course, even larger than that. So that's why you see all these pretty nice things and advertisements to try to pull you in and keep you in as long as possible. Okay, anybody have any questions about that? which we're going to come back to some word problems at the end too. If we have time. Okay, the first way I'm going to show you how to graph them is just by hand and typing them into a calculator, getting your decimal values, or and sometimes, of course, whole numbers, if it works out like that. Let's go back to this part really quick. If your B value is greater than 1, what do you think your graph's going to do? Like if I have 2 to the X, 3 to the X, and I'm graphing, what do you think that's going to look like? It's going to be an increasing graph from left to right. What if you have like negative 3 to the X, something that represents a decay? What do you think your graph will look like then? It's going to be going down, right? So look on your paper at example 2. And they give you, like in some of your problems in math lab, they're going to make you fill in a table of values as well. They either may want the decimal approximation or the fraction. I think they probably want the decimal from what I recall. All right, we're graphing y to the 2x power, and this is positive. So it should be going up from left to right, or falling left, rising to the right. And you have to recall, I wanted to show you guys, of course, we can type it in and get our decimal, but you need to remember what happens when you raise anything to a negative exponent. What does it do with it? What does it do with your expression or your value that you're raising to a negative exponent? It's going to flip it. So if you've got like 2 to the negative third, that flips it to 1 over 2 to the positive third, which comes out to 1 to the 8. And then if you've got, let's say you've got 2 sevenths to the negative 2 power, what does it do with a fraction? It flips it to. So this becomes like 7 halves squared, 49 over 4. So just note that throughout. In the rest of the table, like when you plug this in, this will flip to 1/4. And there's all your decimal values that you use to graph it, and so on. Okay, when you plot all of these points, negative 3.125, and then the rest of them like 0, 1, and so on, you should see that your graph is increasing pretty steeply from left to right. Carbon dating that they use to determine, of course, how old things are, that uses exponential functions as well. Okay, does anybody still need this one up? Okay, let's slide over. What is the difference between this graph of 2 to the x and this graph of 3 to the x? What's the only slight difference? Three to the x is what in this particular area than here? It's steeper, good. It's going to increase more quickly than the 2 to the x. So the greater b is, the quicker that it's going to increase. Okay, going back over how to type these in. 3 to the negative 3, that becomes 1 over 3 to the third. So 1/27, which gives you 0.04. Those of you that have graphing calculators or have used one, do you know how to use the table function? Okay, that's what I'm going to show you that you can use to get these values. And next class, we'll go back over 1 or 2, and I'll show everybody. I'll give everybody a graphing calculator. Which I think Desmos has a table option. Bless you. Okay, guys, tell me for this graph, what is your domain? How far left and right is this function going? Good. It's going to negative infinity, even though it's getting closer and closer to y equals 0 or the x-axis, it's still going left to infinity, and it's still going right. Well, of course, it's going to go right to infinity. So domain would be all real numbers. What would your range be? Range would be good. 0 to positive infinity. It's going down and approaching y equals 0. So what do you put around 0? Good. You put parentheses around 0 and then to infinity. Okay, so you might have a question on how to plug these in, how to graph those points and get your graph. Okay, finally, here we get to a value that b is between 0 and 1, which of course makes your graph fall to the right, rise left. So really all you need to know, of course, is these values, your 8, 4, 2, 1, so on. I just wanted to show you when you raise that fraction to the negative, just like I told you here, remember to flip that fraction. Okay, if you have a graphing calculator, get it out. Go to your y equals area. Okay, for this next one, example 4, type that in 3 to the negative x. And then notice above graph at the top right. Well, I have a T84, but you should see table. So up top somewhere. Access that, and this will give you all of your order pairs. Then you can fill in your table. So notice this giving you negative 327, negative 29, negative 13, so on. And when you graph it, it should, of course, be falling to the right, rising to the left. Why has this graph, because look, our B value is positive and greater than 1, but why is this graph falling to the right, rising left? Why do you think that's happening? Good, you got that negative value with X. So it's taking the graph, you can look at it 2 ways. It's taking this graph and reflecting it over what? If you have a negative, if your X's change signs, it reflects it over the Y-axis. So it's taking that graph and reflecting it over Y. Or you can also think about it like this. What does this exponent, how do I make this exponent positive? You can flip what's inside, then it makes it positive. So this is also equivalent to 1/3 to the X power. Okay, look down at the very bottom. In all the graphs that we've looked at, what did, for just the basic b to the x graph, what is y equals 0 in every graph? Y equals 0 or your x-axis? Okay. Okay, what purpose did y equals 0, the x-axis serve? What is that called? It's approaching it, but doesn't touch it, so it is asymptote. So the characteristics of just your basic exponential function graph, we've already talked about how your domain is all real numbers. For all of these graphs, y equals 0 is our asymptote. So we said our range is going from 0 to infinity. Domains are real numbers. And notice at the very bottom, it tells you that this graph has a horizontal asymptote at y equals 0. Okay, if B is greater than 1, we've already talked about that. Your graph should rise right and fall left. If B is less than 1 but greater than 0, which means, of course, it's a decimal or a fraction, your graph should fall to the right and rise left. Okay, so we'll come back to that back page later on. Let's go ahead and look at some application problems that you have in your homework. One type of application for exponential functions is called inflation. Okay, C is the value that something is now. So the value, current value. What do you think R represents? R is it's your percentage, your rate. And of course, T represents time. So let's say you want to see how much a certain product is going to, the price will inflate after so many years. Yeah. Okay, you have an inflation rate of 6%. House's value currently is $465,000. How much will it be worth in 10 years if it has this inflation rate? So use your inflation formula, go through and plug in. S is the projected value the house will be in 10 years. So that's what you're trying to find. What are you plugging in for C? Good. Plugging in that current value. And then 1 plus, you have to, of course, change your rate to a percentage. So this needs to be what? 106. If you plug in 6, you will get it wrong. And then time is in years, so 10. Okay, it tells you also to round your answers to the nearest dollar. So when you type this in your calculator on your phone or what you have, the projected inflated rate of this house, $832,744. That would be nice. I mean, if you invest that in a house, I mean, you would want the value of it to increase that amount. So that's nice. Okay, this will be the last problem we look at today. This problem deals with the 1986 explosion at Chernobyl. It sent 1,000 kilograms of radioactive cesium-137 into the atmosphere. This function describes the amount, f of x, in kilograms of cesium-137 that remains in Chernobyl x years after 1986. It says even if 100 kilograms of this chemical remain in Chernobyl's atmosphere, the area is considered unsafe for human habitation. They ask you to find F of 80 and determine if Chernobyl will be safe for human habitation by 2066. So 80 represents the years after 1986. And so we're going to see if it will be habitable by 2066. So once again, all you're doing is just plugging in and plugging into your calculator. What did y'all get? Did anybody plug it in? What'd you say? Good. You get approximately 157. So they said even if one, and this represents the kilograms of cesium-137 that's still in the atmosphere. So it says even if there's 100 left, it will not be habitable by humans. So what do you say here? Is it safe in 2066? No. Bless you. Okay, so in this section, don't let the exponential word problems throw you off, okay? Don't let those intimidate you, because more than likely you're just simply plugging in. Well, you are plugging in all of those. Once we get later on in chapter 3, they do get a little bit harder. Okay, we'll finish looking at a small part of 3.1 next week. And your test will be Monday. If you work on your 3.1 homework, you'll probably see some to ask you about compound interest and continuously compounded. So we'll talk about that next week as well. Just do what you can on 3.1.
I was putting it in here and then not really graph.
Oh, I know. Are you in stats?
No,
Oh, okay. This is why. Sorry, I should have told you this. You see how your plot 1, plot 2 have that highlighted? You have to go up because that's like I can't talk. That's a statistical aspect of it. I don't know why I can't say that right now. All right. Anyway, now it should work.
Okay.
Table, and then when you go to graph it, it should graph for you.
Okay.
Yeah.
All right. Thank you.
Yeah, go ahead.
And students, IT would like for us to shut down computers and do a full restart here at school every Tuesday and Thursday. So please do that during lunch today when you get to third block. At this time, even numbered classrooms may go to third block class, even numbered. And please remember to shut down your computer and restart during lunch today. Thank you.
Hey, wait. Where am I? Did they say to go? Did she say to go? She did? Oh, okay, my bad. Okay, y'all go ahead. Go left, go left. Bye.
Odd number classrooms may change classes at this time.
Hello.
How are y'all doing today?
Okay. Back to sleeping a little bit.
I know, it's not. Yeah, my first thought was happy. They were gonna have their first paper test today. And I didn't. On call for 40 minutes. I got sleep in advance, like,
No, I don't think so. Calculus people.
oh.
Question here. Just make the argument or you don't understand.
It's just been fun. I want to go home. I know, that's what I mean, like. I'm not used to this 4 days in a row. I know, right? I'm trying to get used to like, I'm always confused. Yeah, I've been confused for a long time. Projects in like 2 different classes.
Okay, did y'all enjoy your extra sleep this morning?
Yes.
I got 9 of them.
Oh my God.
I know, like I enjoy sleep too. I was just so exhausted. I know you got more, because it's your first week back.
Wait, how did you get pregnant?
I haven't done that yet.